factories. And I've made a small room for the video. If you have only one screen, you can put the video down in the right corner. It will be spaced there on all the slides later on, so you don't cover up anything of the text or pictures. So my name is Björn Johansson, and I'm a professor at Chalmers University of Technology in Sweden, in Gothenburg. And I've been working here since about 20 years. And the agenda for my talk today, I will go, let's see, did it switch? All right, some kind of background and objectives of my talk about myself and about the history of my work so far. And I will go into sustainability and the definition and context of that in relation to XR for factories. And try to explain to you what I see is important with awareness and understanding of using VR, XR, or AR, or digital tools to help decision making for factories. And the key part of my talk will be a lot of examples from research projects we have done together with industry using XR in factory development, both for operator training and also for designing of factories. When I started my studies, I went to upper secondary school on natural sciences. I did acidification of a lake in the forest in Sweden to treat it for a better living environment for fisheries and for the wood. And then we counted number of fishes, and we could see that they exploded in number, and they had a lot of thriving and a good environment to live. And my thesis work in the end of '94 was looking at the roads near to the traffic to see how much nitrogen was emitted from gasoline. And we could measure a number of brown dots on the green leaves to see the closer you get to the road, the more brown dots on the leaves, meaning there is much more nitrogen and ozone that emits and pollutes the environment. Was a part of an EU project. And when I started Chalmers, I went to mechanical engineering, and I tried to find a way to look at environmental sciences, but there was no education at that time to help me with that. So I end up in the production environment. And the picture on the lower right-hand side is from a Volvo car factory, which I built as the thesis work for Master of Science, together with a colleague. It was a 20 weeks project, and we had a mission from the management of the factory. They would like to make 60 cars per hour in the factory. And when we started, they can do 36 cars per hour. So they want to increase the production with almost 50%. So we built using a very expensive computer at that time to build a full-blown model of the factory. So this is the factory from the bird perspective view. You can see small cars on the production line here, starting from the paint shop, going through the assembly shop. Here you remove the doors, and they on the turntable. On the upper right-hand side is marriage point, where you put in the engine. You put in the dashboard in this area here, and you put on the windows over here. This is called ergo line in the end, where you put on wheels and underbody parts. And the door line comes back on this power and free system, and is assembled over here at the final assembly line, where you also fuel up the car. And hopefully, if everything goes fine, you should be able to drive the car out of the production line over here in the end. So we found 5 different bottlenecks in this system, and we used an Octane computer, and Quest was the program from Dassault Systems. And we also used a cube, a VR cube in 3D, so you can actually walk around in the factory. If you remember those cubes with 3x3 walls and floor, you can go in there and have a 3D experience of the factory. And the different bottlenecks we found was, one of them was this removal of the doors took more than 100 seconds. And if you want to do a car in 60 seconds, it cannot be over 60-second cycle time, of course. So this was the most obvious part, which was an obstacle. And then we have obstacles over here after the window assembly, and also part on the end of the long production line in the end, which has a lot of failures and problems with cars not being able to drive off the production line in the end. So 3 years after we made this project, the car factory have installed all of our changes, all 5 different things, and they can make 60 cars per hour. So this really opened up my eyes to see that virtual tools and VR and XR and simulation tools could be really profitable for industry. And I got hooked on this, and I made my PhD last coming years after 99, so 2005. And I joined Chalmers University as a PhD student in the beginning, and I started over the years 3 different companies to be able to help industry and as a consultant work with industry. So I've been doing about 150 projects with industry since year 2000 until now. But I didn't leave my career as a researcher, so I still work at production systems here as a vice head of division on production systems. We are 35 people in this group, and we have 3 different research areas and a large lab that's called Stena Innovation Industry Lab, where we can do all of testing and different things. I will show you this video a little bit later. And the division is part of a larger group of 6 divisions to form a department. So it goes from the user need, the form and function, the material, all the way to production for manufacturing companies. So since we are in Sweden on the west coast, we work a lot with Volvo AB, Volvo Cars, SKF, ABB Robotics, Ericsson, IKEA, and other big Swedish companies. And we also have labs for virtual development in Winquist Lab. This one is Winquist is the founder of SKF in the early 1990s, early 1900s, and metal cutting research lab. And CAM2 is one of the new ones with additive manufacturing. So we have different labs for different purposes. So inside the production systems, I have a group on virtual production systems, where we look at awareness for decision making and helping the human perception using XR technologies. And we try to connect this with the industrial production KPIs, so you can have key performance indicators to understand the production itself, to actually give also decision makers and management the tools to help out when we find good solutions with using XR equipments. And we also try to connect environmental life cycle metrics to see how the performance will improve also environment perspective. So the social part mostly come from the XR experiences and the user interaction. The environmental part comes from the KPIs for environmental sciences, and then we have economical part on the KPIs for traditional industrial production KPIs. So we try to look at reality, work with companies in our research projects. We use the perception of the humans and building models to mimic the reality. And then when we find good solutions in the model, we try to compare it with reality so they are valid and good choices before implementing in the real factories. So for the presentation today, this is the team that's been part of a lot of different cases that I've been working on. We are 2 seniors. Melanie is a postdoc, and I'm sharing this as a professor, and the other 8 people are PhD students working on different projects that you will see in the coming slides. So this is a movie from our lab.
In Sweden's industrial heartland in the center of Gothenburg,
it will show a lot of different XR equipments. So I'll let you look at this for a bit.
Is Chalmers Stena Industry Innovation Lab.
Stena Industry Innovation Lab is a testbed within Production 2030, and in this testbed we are focusing on collaborative robots and final assembly. And we are doing this drone here in this drone factory, and we want to do a real product in order to illustrate hardware and software within this lab.
The drone factory is a realistic production system with a real product. It includes the whole supply chain.
Do you hear the sound as well? You hear the sound? Okay. Yeah, good.
Yes.
Thank you.
Components are ordered from subcontractors performing milling, vacuum forming, and additive manufacturing. The components are then turned into products through internal logistics and final assembly.
C support for drone factory software. The software is used both for the digital definition, but also the digital definition of the process of building the drone.
When manufacturing gets more complex, operators need better support. This can come in form in references. Here at Scilab, we try out 3 different types of instructions that support the operators in different ways.
With a completely digitized product design process, assembly instructions can be created automatically directly from the 3D models. The drone factory is a digital factory, where the physical system is modeled both as sensor data and as cyber-physical models created in a game environment.
My work mostly focuses on to find out how manufacturing industry can benefit from the latest advancements in AR and VR. So, for example, how to use virtual reality for factory layout planning or for training, as well as using augmented reality to support operators in maintenance or assembly tasks.
The drone factory adopts a modularized and event-driven system architecture. We use the Internet of Things platform ThingWorks to create virtual model of our physical systems, and we interconnect them and orchestrate the right data to the right place. In that way, we can create a very flexible production system.
Collaborative robots are designed to work alongside human operators. They are very easy to program and light weight, so they can move around quickly, easily. We in Scilab use collaborative robots to show how we can enable a higher degree of flexibility in production systems.
Technology alone is not enough to unlock the full potential of digitized production. The organization and the people within the factory need to be knowledgeable, empowered, and motivated to share information and knowledge. Both the people and the technologies are enablers for the 4th industrial revolution.
Okay, that's a small teaser from the lab. As you could see on the movie, there's a lot of different XR technologies, Oculus Rift or HTC Vive and point clouds and so on. So I'll go on with the presentation and come back to some more examples in a few minutes. So I just would like to connect with sustainability as well to give a flavor of understanding of what we are looking at in this perspective. So we try to use the Brundtland definition. So try to develop things that meets the needs of the present without compromising the ability for future generations to meet their needs. There are some problems with this definition, but I'll leave it for that right now to give that as an introduction. It also aligns well with the Chalmers vision and mission to see what are Chalmers aiming at as a research partner and educational university. So Chalmers for a Sustainable Future is also something that we try to do in all our research. And we use the triple bottom line as well, as probably most of you have seen, economy, environment, and society. And we try to take it as the strong link instead of the weak versus the weak part that you can see on the left-hand side. The right-hand side means that society has an economy, but society is also part of the environment. So we have to take care of all 3 things to understand how we should work on this. And then, of course, there is always a trade-off, and that comes to morals and ethics, then what you choose. So we have 3 different scales, 3 different things. If you have society on one, economy on one, and environment on the other. For example, we can build a factory that gains a lot of money, and but it uses a lot of electricity power or a lot of waste for the environment, which is not good. So you have to choose the trade-off to try to balance those scales in a good way. And to do the balance in the right way, you need to be aware of what's happening, and that's what we try to achieve, then to get facts-based decision and get awareness high, so you can understand what are the implications if you choose one production way or another way, to see what are the impacts on the 3 different scales here. And we also try to look at this one, Ellen MacArthur Foundation's circular economy picture, which is really high on the agenda now with the Green Deal from European Commission and Ursula von der Leyen. It has a strong connection, and I've been a lot at Brussels lately, but not after COVID, of course. It has been mostly online meetings after that. But before that, was in Brussels almost every other week to discuss this and try to get politicians to do more hands-on decisions rather than just say strategical words and big fluffy things. So try to get it more to hands-on concrete actions. For the next coming part, I will use the Sustainable Development Goals as well. I think this is a quite common way to discuss sustainability nowadays. So I will try to connect those 17 different goals to the cases that I show. So going into the examples then, so we try to go from not understanding the whole complete picture to get awareness and then drive the decision from the understanding and awareness that we find in the research. And all of those research examples I will show you are from collaborative efforts with many actors on a company, often at a company site or in a factory, and together with other institutes and universities around the world, and mostly EU and Sweden then, because this is where we start our work. So the first case I would like to tell you about is a flagship project on from the Baltic Sea region here in the northern part of Europe, looking at shipping. So how can we bring eco-efficiency and digitalization to maritime industry? It comes well in hand for the previous presentation, actually, with the harbor and the crane operators. So we have been doing a lot of work together with the shipping industries, the shipbuilding companies, and also the trades with the operating of the ships. So the first thing we did was one of the DFDS seaways. We did a 3D scan of the whole complete boat. This is a DFDS seaways Crown that was in a dry dock in Denmark a couple of years ago. And when they build a ship like this, they are building different sections one by one and then adding them together. And to understand how they join together, it's more like a puzzle. If you would like to connect one part to the other, it has to fit in the end. So in Klaipeda, they have a production site to build those parts. So here you can see 2 different sections, one A and 2C on the CAD drawing, and one of them are actually on the right-hand side, the real one. So when they build it in Klaipeda, they're sending those parts to Finland, to Åbo, and this is quite a long distance in between. And the shipment takes some weeks. And when the new part arrives, it's not going to fit the old one that are already there in a perfect match. So then the problem is then how can we predict the fit and understand the fit before it actually arrives? So then we do a 3D scan of the new part and put references points on it and measure it with a millimeter accuracy. So we have done some work in the production site in Klaipeda to do 3D scanning of those parts. And then when you compare one part with the other, you can see there's differences. So here is 1A and 2C again. And you can see there's a big difference. -11 and plus 11 and -12 gives 23 difference centimeters here in this gap. So it's quite a big gap. And it means if they send the real physical part and when it arrives, it's not going to fit, they have to remake it or remodel it. And it takes many weeks to do that, to cut a hole, to climb inside and to weld and paint and everything again. So it takes a lot of time. So this is the old way to do it. Make a block construction in Klaipeda, transport it, and then paint, assembly and adjustment in Turku in Finland. So our proposed new way to do that is to make a virtual model of the Klaipeda block when it's done, and then send this virtual block to the production site in Turku. So the adjustment is not going to be needed anymore. You can already assess deviation and plan for the adjustment before the part arrives. So you gain several weeks of production time, and you gain a lot of easier way to actually make them fit before they physically meet each other. So looking at the trade-offs in this example, we can see the first time right gives a lower environmental impact, better control of the process and less rework, and a lower total cost. The negative part then will be requires a new routine involving more interaction between the companies. And it also requires new skill set and equipment to do this kind of work. So now the Klaipeda Harbor has bought a 3D scanner and taught some employees how to handle it to make this 3D point cloud and so send it to Turkey. So they're already implementing this kind of change to gain the positive impacts. Another example is a 3D VR environment for factory development and operator training. So we have done some models here as well, and I will show you two of them today. One of them is from SEVT, a car manufacturing company that's located here in Gothenburg, but they have all of the factories in China, so it's quite a lot of travel for them. And also the Saab airplane, JAS 39 Gripen, was sold to Brazil with a government contract. I think they sold 35 airplanes, but the requirement from Brazil then from Brazilian government was, if we buy those 35 airplanes, you have to produce them in Brazil. You cannot produce them in Sweden and send them to us later. So they want to increase the knowledge and understanding and also make the work happen in Brazil to gain the skill set and also the economical benefits from building in Brazil. So that makes it also really good for AR and VR applications to be used, since most of the development is here in Sweden. So the core elements for this is data for the factory. The software, we have 3D point clouds, we have HTC Vive and Unity environment, and hardware, of course, and the user perspectives, and then the operator who's going to be inside. The point cloud, I assume you have seen before, but the point cloud is a 3D image of the real factory that is collected with a 3D laser scanner. It rotates around its axis and also spins a mirror on the vertical part to collect all of the points. And it collects about some 100 million points in a few minutes and put a color photo on each of the dots that it finds as well to get a real good 3D representation. And here is some of the different softwares we used and SDKs. So Unity, Stream, Photon, Leap Motion. Probably you have seen some of those. Avatar SDK to get the multi-user as well. And PUN2 for multi-user platform, which we have integrated all of it. It will be a movie in a few minutes to showcase this. And then this is the hardware, HTC Vive, as you have seen. And we also built a mock-up of one of the weld guns with some simpler ways to just get the feeling when you hold it in the right way, and attached one of the controllers on it. This is one part of the research. So one of the researchers, Yang, who you saw on the movie earlier, he will present his PhD thesis within a couple of months now. He have done a user-centered design method or toolkit that you could use to plan the work, do research to find out what is possible, design the XR environment, adapt it, and measure the output from different user perspectives. When it comes to the result of those two cases I will show you now, I would like you to understand the implication on environmental load as well. If you look at the CO2 emissions and greenhouse gases per ton, per person, one example could be Sweden, then it's 4.5 ton per year, CO2 emissions. If you travel with a Saab, for example, to go to the Brazilian plant, 4.5 per year for Sweden. If you travel from Sweden to Sao Paulo, where the plant is now, it's about 2 tons CO2 emission per person return trip. So more or less, if you travel 2 times to Sao Paulo and back in a year, you have used up your quota for CO2 emission. Then you cannot eat, you cannot drive a car, you cannot even breathe. because breathing is about 1 kilo CO2 emission per day, so 365 kilos for a year for one person. So it's quite a lot of emissions. So this is also one benefit. If we can do it with a VR or online, we can earn a lot of emission reduction from this kind of technologies. So next slide is a movie from the Saab plant. This is before they built it. So this is the real facility. It's a 3D point cloud with the walls and pillars. And then they have used all of the CAD drawings for the different production stages for the airplane assembly with the CAD drawings from the Swedish plant to see that it fits, and they can have operators walk around to look at the new workstations to get a look and feel of, is this a good workplace for me? Do I want to move one of the tables? Do I need some more equipment or bins or something that is not going to fit around me? Is the space big enough? And also, is the things nearby to me what I need to use for my next step in the production? For the next example, we have the Sevt car plant in China. It's a similar way. It's not as far travel. It's about 1.5 tons CO2 turn return trip per person. So you can go there 3 times in 1 year. But then again, you have used up your CO2 emission for the year if you want to be on average with Swedish emission for a regular person. And in this case, we also did some user testing. So this one is from Hanover Fair in last year. So the users here is the Swedish President Stefan Löfven and Angela Merkel, the Bundeskanzler in Germany. And here you can see the weld gun behind you. This is a mock-up of the weld gun printed in 3D printed weld gun we could use with this 3D environment. It's quite heavy, so it's not that easy to use for VR example, but it's definitely good to have as a comparison. And we also had another user to test it. This is the Swedish prince who was in the fair as well. So the prince is right now in China building a car that not even exists yet.
Welding in VR, and he did it quite fast.
So if we look at this on another perspective, this one is the multi-user VR that we have been doing as a next step. So you can be more than one person in the same factory. It allows up to 20 people to work collaboratively to design the factory or test this spot welding that you saw on the previous movie. So this is quite interesting for us to take as the next step to see what can we do more to reduce the travel. How can people collaborate in the factory without actually going to the factory in another country? So here you have 2 different spot welding guns, and Liang now will try to assemble 4 different metal parts for a new car in a new fixture that is not also existing in reality yet. So testing the fixture, reachability, collision detection, and he will get help from Jonathan, who is tutoring him from the side to show him and tell him what to do. You can see the shadow where the part should be, also the green shadow before it snaps to the right place. So even if the operator don't know where to put it in the beginning, he can get some help. And now clamping the fixtures and then getting a spot welding gun to spot weld on the pink dots on the metal part. So now Jonathan is taking over to take it out, the done pieces, 4 pieces spot welded together to one. So in this case, it's also, of course, less travel. If you can collaborate virtually in the same physical factory without actually going there, that could be a lot of benefits. It will be a lot cheaper and faster and give a better solution from the beginning. Operators can be involved early, so you can involve more personnel and they can train the tasks before they actually have the real car coming into the production line. They already know it when they arrive in the physical part later on then. So they tried a lot of assemblies before to understand how it works. And they can also be involved in designing their own workplace. A negative part, of course, I could feel myself, there's less social contact if you don't travel to the site. I can feel myself already. I didn't travel since February this year, and it's quite not the same to work from home, from office all the time or from home. It could lead to some misunderstandings if you cannot see the expression of people's mind or face. It's more like a static face in this kind of avatar. And of course, the model needs to be updated if something changes in the factory, and it also requires new routine and skill set for the people that works with it. But I think definitely the positive sides is a stronger one than the negative parts in this. Next case is about a brownfield VR relocation of machines in a factory with GKN Aerospace. They do engines for aerospace business for Boeing and big companies, Airbus and Boeing, for example. So with brownfield, what it means is this is kind of greenfield, right? This is no factory here. If you build a factory here, it will be called a greenfield factory. But if you have a factory already, physical factory, and want to change something inside, it's called a brownfield, since it's already there and you change something. So in this case, we are going to put new machines in an old factory and update the places. So again, we used the 3D point cloud scanning for the facilities around the floor and the ceiling and the pillars. And you can see the CAD drawings of the new machines. So in this model, operators can also walk around to make themselves at home, to understand what it looks like. How would I work here? Are the benches big enough? Can I get a room to open the hatch for a maintenance engineer, for example? Are the machines too tight together, or is this a good layout? So a lot of interaction with people that would work on the factory later. So the results from this study, and we worked together with GKN, and we were a participant observation study. So quantitative method to collect data where the researcher gains insights into more specific context to identify unknown problems and suitable solution as we learn more along the way. So the project was actually run by GKN, and they used a lot of people to go into the model to give feedback. So this is the point cloud from the top view. And then you can see there's different perspectives. The pillars, for example, when we try to align the point cloud with the real factory on the blueprint, there is a deviation of 0.37 meters. So it's quite a big difference. It's like one footstep wrong. The pillar is on the wrong place in the blueprint from the beginning. So when they built the factory, they didn't follow the blueprint perfectly. They have some deviations, and we found those deviations once we 3D scanned it. And that's important, of course, if you would like to put a machine or something here or have a forklift drive past, it's not going to fit if it's a tight area. So definitely good to know when you're trying to redesign something. And then when it comes to the changes, we used some assets again, some machines, and we used the power beam, of course, some opening in hatch in the end here. And also the incoming material was the same. And this machine was still there. We didn't move that one. But you see a lot of changes were done, and operators had a lot of discussions with us, and we update the 3D model to make changes. For example, they need bigger tables next to the machines. They have one machine that was really tight next to a wall, and they tried to go inside, and they said, this is fine, this is not as tight as it looks on the drawing, so they could be comfortable, didn't feel squeezed in between the wall and the machine, so it was actually placed there. And here in the center, they wanted to have a big open space for lean management and boards to have meetings. So we moved one machine a bit further to the left as well to get a bigger open area to have discussions in the morning with all operators. So quite a lot of changes before they actually built the factory from this work. And that's a good positive thing. So the positive parts here will be then cheaper because they don't have to redo anything. Faster and better solution was done, and we involved a lot of operators and maintenance engineers. So once the factory is actually up and running, they are feeling at home and feel involved in the development process, and that's a really important step as well. And similar negative things then, it needs to be updated if they want to use it again, and requires new skill set and routines if they would like to use these VR development tools a lot. Okay, the next example is from a factory design at Volvo. So here we have put the factory on a table inside a VR environment. So you actually can walk around the table and look into it as a small factory. We scale it down. So we have interactable design of the factory resources. You can move robots, you can move machines and things. They are independent objects, so you can actually relocate it when you are in the factory yourself. And then we have done some questionnaires and interviews in the end to see what do they think about this environment and how can they use it for the future in a good way. Here you can actually go into the factory, zoom in if you want to. You can pick one part of it and go inside. So now Liang is going into the firewall cell, and he would place a new robot somewhere in this layout to see how it could fit. Remove the old one and get the CAD robot instead. And on this one, there's also linked some KPIs on the production to see what it's producing right now and what are the performance of the robot. Saving it to the layout so somebody else can go in and see his proposed layout. So then we had some users testing this environment, and the results here, you could see some graphs about it. Probably should have changed the color of agree from red. So strongly disagree should be red. I think this is a bit misleading. But all in all, they think they are agree that this is easy to use with clear benefits, and they can recommend to use it for the future. Some people disagree that it's easy. I think it's the green part here is disagree, 2 people. And I think it's because they're not used to the hand controller and HTC Vive and Unity environment. It's quite new for somebody who didn't try it before. But if you get acquainted with the control, I think it's going to be quite easy. And we also had some feedback that the people were dizzy when they used it. A couple of the people here got dizzy in the end. So not being in the environment for too long, maybe 15 minutes or so is enough. If you stay there for a longer time, you will have a hard connection to the real world since the virtual world is a bit different. The balance is going to be offset a little bit. So here in this one, we also involved a lot of more personnel, decision makers, operators, maintenance engineer, logistics people, robotics, programmer, and so on. And it gives a good overview, and it's faster development than actually sitting on a flat screen or trying to do it with a blueprint. So it gives a better solution in the end. But also here again, it needs to be updated. And now we have worked together with ATS, a company that works with a point cloud and 3D imaging of factories. So they have developed a PDM system that you can actually keep version handling and updating the factory in a really easy and smooth way. And it also requires new routine and skill set, of course. This comes back then to the users that they are not used to this kind of environment to work with it for everyday work, everyday purpose. So we could see then that the conclusion is that sustainability awareness and digital tools are increasing in industrial practice. We can see that it's useful, it's getting easier to use. I mean, 3D scanning, for example, has been around for 20 years or so, but hasn't been accessible in an easy way. A lot of deviations, and the color is misleading and not really useful. Now with stronger computer power and also the nice VR and XR equipment, we can use it in a smarter way. And the presentation I showed shows a lot of examples for the implementation that were successful, and of course, everything has a positive and a negative side, but I think the positive sides on those really comes on top of the negative. But also we have to strive towards more circular economy and look at the social and economic well-being as the same, with the same time as taking care of the environment. So next steps for me is to look at more projects that use virtual tools for sustainable production. Look at several KPIs on sustainability awareness and assessment with those models, trying to connect back to the actual production flow. And then we have new projects coming up with VR and AR solutions for multi-users, so we don't have to travel around for factories. We would like to stay in the office and meet each other in a more near way, so use the avatar picture of your face and connect with sound and touch, and maybe also force feedback could be possible. We have some minor work on that for now, but we have good connections with others that are working on force feedback as well. And then we are involved in standardization activities with the National Institute of Standards and Technology in the United States. We have had 8 people there for the last 15 years. I've been there for 2 years myself as well, developing standards together with them on how to represent data for manufacturing. And we also get involved a lot with Science Magazine, trying to get some publication in there. It's not easy, but I'm working on it a lot. I'm part of the organization of AAAS now for the February meeting to host a session. And we hosted a session before on 3D imaging, where Obama was 3D scanned, and we had some relics 3D scanned, and also crime scenes as well as factories. And then, of course, the teaching part. I have 3 classes at Chalmers and quite some PhD student that helps me a lot with the research conduction and a lot of industrial contact, which is really good. So that would conclude my talk for today. And if you have any questions or would like to discuss something, I'm definitely open for it. We have 15 minutes left until the next presentation.
Thank you, Jonathan. Thank you. It was really interesting. It was clear, and yeah, I think you have a lot of projects that they will impact deeply our environment, our society, and the economy. So I will give attendees and panelists the chance to ask their questions if they want.
Hi, I have a question.
Okay, Catherine.
So first, thank you for a very interesting presentation. I wonder, do you have any collaboration with our university, NTNU? Because I think some of my colleagues mentioned similar approach.
Sure, we have
circular economy and VR visualizations and circular economy.
Yes, we have right now. I'm not part of a project with NTNU, but we have previously been in contact and done some EU applications for research and so on. And we have visited. Some of you have visited Chalmers, but right now we don't have any collaborative project. But definitely we can think about it for the future.
Okay, and I wonder, those factory simulations, are they kind of digital twins? Are they updated somehow in real time, or they are just static?
We have many different versions of that. So we have digital twins. We're right now building a digital twin of the drone factory that you saw in the beginning, with the Siemens plant simulation and MindSphere and connection to Azure platform and so on. So that is ongoing right now. Most of the models we do, we try to take a copy of the real world so we don't interact or distract the real factory. For example, if you want to build a car, 36 cars per hour in the factory, we run the simulation for 1 year worth of production. So it's not going to be real time. We have to fast forward it. So 1 year will be produced in half an hour on the computer or so. So digital twin in that sense is not going to help a lot, but to understand what's happening right now, definitely digital twin is possible, and we can overlay the data in the real 3D environment.
Thank you. And last question, how do you deal with the lack of haptic feedback? I mean, it's important to understand several processes, the weight, the feel, so on.
All right, that's a hard part for us. We didn't use a lot of haptic, as I said before. We have looked into it, but we tried to. We did not try to use it for now, but also depends on the purpose. Since I work a lot of factory design and development of the factory. In my model, you can lift a machine that is 4 tons heavy with one hand, right? No problem, because it's a virtual model. And I don't really think it's necessary to have haptic feedback on lifting this kind of things or moving it around in the layout. If you are talking about assembly or small bits and pieces for operation for one person that assemble a cell phone or something, that could be really interesting with haptic, because that comes to the skills of the fingers with leap motion or something, for example. But we didn't do a lot on it. We used leap motion a bit for assembly. We tried it in our models also for layout planning. But the gesture control with leap motion is not really a big benefit for us in comparison to the controller when you design a factory on the big scale, but rather good for small things, for operator assembly and so on in that case.
Thank you. Have you started using HoloLens too?
HoloLens we have used in the drone factory as well.
But have you started to use the second one?
No, we did not try that one yet.
Thank you.
But I think the previous presentation you talked about shipping. So I didn't plan to include that in my presentation, but I actually have some French student worked with us a couple of years ago, and they did a game for shipping industry as well. I'm sorry about the French. I don't even speak French myself, but you can, if you would like to see some pictures, we can still take a look. So they did a game for loading the ship, so it's not going to fall over. Where should you put the different containers in order to have a good balance during the load? So we have different skill levels for the loading, and then you have to put your different containers in different places. And if you fail, it will fall over. And here you can see the gravity point, if it's going to lean back or the other. So you have to use the ballast water to balance it up. So the best way is then to not use ballast water, to actually put the containers on the right place from the beginning. So it's more like a Tetris game where you have to balance the ship so it's not going to lean in any way.
I see. Thank you.
And then you have different sizes of the containers or different weights of containers. And then it's more like learning objectives, quite simple game for a person that experienced. But if you're new to the job, you can give a good understanding of the people. Why do we put the container here and there? You can just put it anywhere, but it's not really a good way to put it anywhere. You have to balance the ship while loading it as well. Not only the final load should be balanced, also during the load. Okay.
I think Diego has something to say.
Yeah. Thanks for the presentation. Very interested. I'm also interested in having more information related to supply chain and logistics. So how can we apply virtual reality to transportation? I saw it is more developed on production environment. and you saw recently the simulator for shipment and for seas. But do you have any experience or any knowledge in other logistics environment or transportation, such as aircraft, such as trucks, such as warehousing, and so on? How developed is VR or AR in this area, if you know, if you have experience on that?
Yeah. For logistics as external logistics from the factory, I don't have a lot of experience. I know that other people are designing the cockpits in aircraft and so on with the VR and AR. But for the use from my side, I did not do that kind of user experience inside the cockpit. Since I'm a production systems, I more look at the internal logistics in the factory. Then we have used it a lot. That's many companies and many cases we have done. Especially when it comes to brownfield installation. If you want to refurbish something in a factory, we are using the 3D environment, 3D scanning to get a real nice, good view of the real factory. We clean out what they want to remove from the old machines. And then we install the new machines in CAD, and people can then walk around and discuss and see where should we put the machine, or where should we have the incoming material, where should we have the conveyor belts or robots, how can we do maintenance in this machine if we put it here, can we reach all of the places, or is the operator going to work good from this site? So internal factory, there's a lot of things, but external, when it comes to GIS or landscaping or driving trucks or airplanes around, I did not try a lot of that, but I don't really. How do you see any benefits from that kind of VR experience, to see the truck driving on the road? Is it really VR worthwhile? Or what was is that what you meant?
I mean, for instance, kind of simulator to upload, goods to a truck in order to improve the uploading efficiencies and so on, and also it could be applied to aircraft and so on. But I don't know if it exists already or not. That's why my
Okay.
question.
I understand. So uploading things for actually transport. Then we have done some work with ships again. Loading and unloading of ships inside the cargo space. We have done 3D scanning of inside of the ship where you put all the trucks. And then it's also similar to a Tetris game. How can we unload and load the truck in a good way? Because there's two-way communication during that drive. So drive off and on the ship. And a ro-ro ship, it's not easy.
Okay.
So the one ship I showed you before was the container was lifted on. So that's another thing. But if you drive on and off, it's going to be really cramped on the logistics parts. So here we have tried some with VR as well.
Okay. Do you have any name or contact for this experiment or company that is working on ship and sea uploading?
Yes, I will show you. Let's see if I can find there's another PowerPoint and I have to, this is the one. So this is the Interreg Eco Prodigy Baltic Sea Region project that I showed you, the flagship project. I can send a link for the homepage. There's many things on that site if you would like to check.
Okay, wonderful. Thanks so much.
Here is one of the 3D environment, and so drive on and off the ship. So there's congestion going to happen when you try this. Let's see if there's a movie as well. Okay, no movie in this one. Sorry about that.
Okay, no problem. Thanks so much.
I can put it in the chat window, the link to the webpage now. And if you need any other personal contact, you can just email me if you want, and I can get you in connection with those people.
Wonderful. Thanks.
No problem.
Thank you, Diego.